Hey guys, so today we're going to do section 8.4, Binomial Theorem. Alright, so when you think of a binomial, what do you think of? So a binomial is a polynomial that has two terms. So in this section, we're going to talk about raising that binomial to a power. So let's take a look at the most basic binomial, x plus y, raised to the n. And let's just focus on taking a look at some powers of that binomial here. So take a minute. If you did x plus y to the 0 power, that equals 1. Anything to the 0 power equals 1. X plus y to the first, that's just itself. And then we keep going. Squared, cubed, fourth, fifth, and sixth, and so on. So take a minute and look at what x plus y and all their powers equal here. And list anything that you notice about number of terms, the coefficients, the exponents on your variables. Alright, so a few things to take note of, if you didn't already. But this is just the same exact thing as the previous slide. Alright, 4 specific observations. There is one more term than n being the power. So right here, your binomial raised to the 4th power, there is 5 terms, one more than the exponent. Second thing, x and y have symmetric roles, meaning, take a look, as the power of x decreases from 6, 5, 4, 3, 2, 1, nothing, because x to the 0 is 1, so it wasn't there anymore. The powers of y increase. None, 1, 2, 3, 4, 5, 6. So that's symmetric. The sum of the powers of each term is n. So look down here. If we're looking at to the 5th power, x to the 4th, y to the 1st, 4 plus 1 is 5, or 3 plus 2 is 5, or 2 plus 3. So the powers of your variables add up to power you're taking. And the coefficients, if you saw, the coefficients are symmetric as well. So 1, 5, 10, 10, 5, 1. Meaning if you cut it in half here, these 3 and these 3, you go up and then down the same pattern. So 1, 4, 6, 4, 1. There's an odd number, that means the middle one is going to be by itself. The even number ones, you have each one has 2. Alright, those will come in handy later in this section here. Alright, so someone came up with this formula here, so take a minute and write this down. Alright, so the coefficient of each term in your binomial expansion can be found by doing n choose r. That's how you say that. And the symbol that you may see is also this. That means the same thing as n choose r. So let's take a look and evaluate part A. 8 choose 2. So we're going to plug in to the formula. So 8 factorial. Remember previous section we learned what factorial was. N minus r. So 8 minus 2 factorial times 2 factorial. So 8 minus 2 is 6. So 6 factorial times 2 factorial. And 8 factorial really is 8 times 7 times 6 all the way down to 1, which is really just 6 factorial. So I'm writing it like that because now our 6 factorials will cancel. And 2 factorial, I can rewrite that as 2 times 1. So 56 times, or divided by 2 times 1, 2. So 8 choose 2 is 28. This here saves us some time than having to write out 6, 5, 4, 3, 2, 1 twice and canceling out every single one of those common factors. Alright, take a minute and try part B. That is the same thing as 10 choose 3. Using the formula, go ahead and solve that. Alright, evaluating 10 choose 3. You would get 120. Notice the 7 factorials cancel here, And we have a little bit of math to do. So multiply out 10 times 9 times 8, and then divide that by 6, which is 3 times 2 times 1. Alright, take a few seconds and try these two problems here. Remember that 0 factorial equals 1. That will be helpful in both of these examples. Plugging these into the formula. 7 minus 0 is 7 factorial, so those would cancel. 0 factorial is 1, so this one is 1. And the same thing happened here. 8 minus 8 is 0, and then what's left over here, 8 factorial. So both of these answers are 1. Alright, expanding a binomial. We are going to write the expansion of this expression. So what we need is to focus on the coefficients of our binomial expansion, and all of them are going to be, the coefficients are in the form n choose r. So 3 choose 0, 3 choose 1, 3 choose 2, 3 choose 3. The first number being the power we're taking, and then we go from 0 up through the power. Alright, so all of them are the coefficients. All of them are the coefficients. So 1, 3, 3, 1. So 1. We'll remember about the x and our y of our example. So the powers of the first one start at the highest and go down. So this is x cubed, nothing for the beginning one, plus 3 x squared, 1 squared, 1 to the first, excuse me, 3x 1 squared plus 1, no x because it was x to the 0, which is 1, and then 1 cubed. Simplifying all that out, you would get this cubic polynomial of 4 terms. How would this example change? Instead of it being x plus 1 cubed, now we have x minus 1. So let's take a look back at what we had previously here. What would change from this positive 1 to being a negative 1, looking at our 4 terms here? These coefficients will all stay the same. Our powers of x still stay the same. But instead of this 1 here, it's a negative 1. So looking at here, we would have negative 1 to the first, negative 1 squared, and negative 1 cubed. So those are going to change a little bit. So let's copy this over. I don't know if I just want to have it here. Oh, good. Alright, so instead of it being positive 1 here, we're going to have negative 1s. So the ones that are going to change is negative 1 to the first and negative 1 cubed, because negative 1 squared is still positive 1. So we need to change these two pieces. We need to change these two pieces to be negative. So our final answer for this expansion will be x cubed minus 3x squared plus 3x minus 1. So all the work of the coefficients and the exponents stay the same, but we just got to be careful of our signs here, because technically that is x plus negative 1, that whole thing cubed. Alright, write the expansion of these two. I'm going to show you the first one, and then you'll do the next one on your own. So 2x plus 3 to the 4th. So now we are going to be doing 4 choose 0. 4 choose 1, 4 choose 2, 4 choose 3, and 4 choose 4 for the coefficients. So go ahead and find those coefficients. Alright, the coefficients are 1, 4, 6, 4, 1. And now we are going to add in the powers of our x and our y, our x being 2x and our y in our formula being negative 3. Alright, so plugging that all in, our x, 4, 3, 2, 1, none for our exponents, and then for -3, none to the first, to the second, to the third, to the fourth. So go ahead and pause and simplify all of this out, being careful of exponents and order of operations. Alright, so this is the simplified answer for 2x minus 3 to the fourth power. If you want to take a look at what the answer for part B would be, that is in your textbook in section 8.4. Alright, so pause and write this part down. Notice they say r plus 1 term, so if they're asking for the sixth term here, our r is 5. So r is 5, our n is 8, x is a, and y is 2b, so we're going to plug all this into the formula. Alright, so the sixth term of this binomial here is 1792a cubed b to the fifth. Notice we plugged in 8 for n, 5 for r into our formula up here, and our two pieces a and 2b, multiplying all of that out, being careful that we raise 2 to the fifth as well. Alright, find the coefficient of the term a to the sixth, b to the fifth in this expansion here. So which term is that? Well, b is our second piece here, so that's going to give away what the r is. And our n is the power. So go ahead and plug in each of those pieces into your formula. If you're having trouble plugging into the formula here, 11 choose 5, 2a to 11 minus 5, and -5b, be careful because this is negative here, to the fifth power. So go ahead and solve all that out and find the coefficient. Alright, so the answer will be -92,400,000. Alright, Pascal's triangle. So, Blaise Pascal came up with this triangle here. Let's take a minute and look at this. So, it's arranged in a triangle. Oops. And the number comes from adding the previous two right above it. So this is what the triangle is here. 4 plus 6 is 10. 10 plus 5 is 15. 15 plus 6 is 21. So why do we care? Well, the first and last numbers of each row are 1 here. And Pascal noticed the numbers in our triangle here are the same numbers of the coefficients of the binomial expansion of x plus y. So if you remember back, we did that x plus 1 to the third power, and the coefficients were 1, 3, 3, and 1. So it's a special triangle here that helps you remember the coefficients. So using this here, using this Pascal triangle, we have the first 7 here. Notice the 0th row because you're raising it to the 0 power. So the third row is the third power. How can we find the 8th? So x plus y to the 8th. How can we find the coefficients of that? Well, we're going to use the 7th row to help us. So always starts out with 1, so the first and last, and then we build. So 1 plus 7 is 8. 7 plus 21 is 28. So what I would like you to do is finish off to find the remaining coefficients of the x plus y to the 8th binomial expansion. Alright, so the remaining ones here, also notice that it's in the pattern where increasing and decreasing, and it's symmetric. There's an odd number for this one, so 70 is by itself in the middle. So if you were to just do 8 choose 5 and solve for it, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 8 choose 5 would be 56. Also notice on your calculator, menu, probability, 3's combinations. You do n comma r, so 8 comma 5 is 56. And that's what we got there. Alright, thanks guys.